In this video, we're going to see the balancing means method applied to a slightly different kind of question. Let's have a look. In a class, we've got 12 girls and 16 boys. There are two groups. We know the mean mark for those boys was 28 in a test. The whole class has a mean of 34. We would like to find the girls' mean. So let's think about how we use our balancing method for this question. Step one is we always draw our number line. We need to think a little bit carefully about which group to put at either end. So if you look here, the boys have a mean of 28 and the whole class has a mean of 34. That means the boys have done worse on average. So the boys are going to be down at this end, 28. The girls are going to be at the other end. We don't know their mean, but we do know the combined mean was 34. So let's mark on here, 34. So our next step is thinking about those forces that pull down at each end of the seesaw. Well, there were 16 boys. So 16 is the force at this end, and on the girls' end there was 12. Next step in our method is to think about the ratio of these two groups. So we can say boys to girls. There's a ratio of 16 to 12, simplifying that as 4 to 3. That means, because the forces are in the ratio of 4 to 3, the distances must be in the inverse 3 to 4 ratio. So we can fill in this ratio. On this side it's 3. Make a note, that's 3 parts. On this side it's 4. We still want to do the same thing as we would do before, and that's find one part of our ratio. If anything, it's easier than we have done before. Here we've just got 3 parts, and the distance between the boys and the mean is 6. So if 3 parts is 6, 1 part has to be 2. Likewise, on the other side, we can fill in these 2's. That means this distance here is a total distance of 8. So from 34, we can add on 8 to get the girls having a mean of 42.